I think tonight we've got a speaker who is from not anything to do with leakage or water even. I think his bag is robots. Would that be right, Pete? So I'm pleased to say we're going to have a discussion that is nothing to do with what we've done today. A nice change, you might say. So without further ado, I'd like to introduce Mr. Pete Felton. I've got to read this off my bit of paper. He is from the National Robotarium. Put your hands together for Pete.
Thank you very much, Bob. And thank you very much to Judith for setting this up. Right. So, I only just made it here tonight. I got a bit lost and had to ask a robot for directions. It took me all around the houses. It turned out to be an R2 detour. You have to try, don't you? Right, so the National Robotarium. Just going to show you this little logo which comes up. This is someone really smart designed this for us. So it's a combination of ones and zeros and AI, which becomes the Robotarium, which I think is just really, really smart. But it does remind me of a maths joke. So I have to see who laughs at this one. If you don't get it, I'll give you a Maths 101 lesson later. So, National Robotarium, so 3 words. First one, Robotarium, somewhere where robots live. And that's basically what we do. We bring robots into an environment where we can help people use the robots, learn what the robots do. And we build up a repository of robots from things like this, an autonomous surface vehicle, robots with arms, robots with legs, for all sorts of uses. And by building up a repository, we can then help people when they need a robot to solve a problem. So lots of quadruped robots and humanoid robots. And this little chap here, who's going to pop up, has got all the joints in a human body. So that's a really, really complex one. It's quite a short little chap, but really, really detailed. That was a really big one. It's a human-sized one, which I find a bit scary. And then Pepper is a really cute little one. Cobots here allow you to work alongside them, so you won't actually interact with the robot. It won't hurt you. It stops if it detects you're next to it. And those little ones are used for neurodiversity, so you can train people how to interact with pets and humans. So if you stroke them nicely, they go green and purr, and if you're a bit rough with them, they go red and growl. And that one in the middle there is agriculture. So that scans a whole field and finds all the weeds in it and tells the farmers exactly where the weeds are. So instead of spraying the whole field, you just go in and take out each weed individually using a little flamethrower or laser. National is because we are UK national, we're not Scottish national, although we are based in Edinburgh at the Harry Watt University. So all these robots we use to solve people's problems, and we work across loads of sectors. There's a few down there. You'll notice that utilities is missing, but we do work with utilities as well. I work in space and nuclear, construction, manufacturing, transportation, subsea, onshore energy, offshore energy, so I basically do most stuff. But we also do loads of stuff in the healthcare domain, and we do use robots working alongside humans to try and make sure that you can remove the healthcare expert and have a robot helping them out, which gives you more human capital to use. We work across lots of universities, bringing as many ideas as possible. We don't want to solve all the problems, we want to bring people in to help us solve problems. And we don't supply just one kind of robot, we work across all robot types. So what we do, using robots and AI to get people out of the dull, dirty, dangerous jobs. And also, if we can, we turn things dark, because robots don't need light, and there's only heat, so it can help to save energy and be better for the environment. Help us to be productive. So if you start to take people out of the dull jobs, you can train them up to do better jobs. So there's a shortage of skill sets in things like construction. People are very nervous about robots taking jobs away, but if you can take those jobs away and give them a better job, give them a better quality of life, that's a good thing. We do loads of outreach. We have 2 schools a week coming in to train them on how robots are working and what they can do in the future with robots. And we also help to try and set some policy as well, so that you get the best out of robots. You're not just doing robots for the sake of it, you're doing robots for a real reason. Load of stuff about how we do it, lots of collaboration. We've got lots of hot desking, so people come and work alongside us. And we try to be as easy as possible to work with. But the main aim down here is having a positive impact on society, the economy, and climate improvement. So that's really what we do. We've got 3 at the moment, startup companies working alongside us, and they get access to all our facilities, and they actually get access to our engineers as well. And we've got robot systems engineers, mostly with PhDs, really, really smart cookies, who come from all the universities, very international as well. Up here we've got outdoor test center, so there you can do rapid aging of robots. So we've got a test lab, a test rig outside where robots can go around and do exercise every day. And you do that for about 3 months, do 6 laps a day, and you see what fails. And that's designed so that things like the oil industry, where you've got robots out in the middle of nowhere for a long time, you know what's going to fail and you can start to plan for that. And loads of robots down here as well. So, we're all used to having robots that cut the grass, robots that do the hoovering, robots that do the dishes, although this one that's coming up is a bit more advanced than the standard dishwasher. And people are even trying to get robots doing the ironing, which is a bit more complicated. But what we're seeing is that more and more companies are producing humanoid robots, and you will have robots doing all the jobs for you, even looking after the baby at the same time. But one of the things that also happens is that people are using robots in cars. You don't call it a robot car, but it is a robot car. I've got a Tesla, I've driven 120,000 miles, and about 80,000 of those has been in autopilot, so my car is driving for me, and it's just fantastic. But robots can be used for the wrong things. However you invent something, you come up with a new machine, a human or a cat will do the wrong thing with it. You see cats sitting on these little robots because it's a lot of fun. Robots take all sorts of shapes and sizes as well. So this is a bit of smart stuff. Come on. It is a robot. It looks like a plastic tube, but it is a robot that can be controlled and moved around. Could go down a pipe. It can push itself through hazardous situations. Really good for going into places like disaster zones where buildings have fallen down. You can get these things into it. So it's very different to normal robotics, but it is a form of robotics. Snake robots are very big. We've got a load of soft robotics now where you can get multiple sections and you can push it through a hole and move the end of it round inside a building. So for things like nuclear decontamination, you can get these things into places that you couldn't send humans. All moving in really strange ways. So it's a very fine definition between what's a robot, what's automation, and what's a machine. And some of the things that's coming up next are really big machines that actually are robots. Things climbing up different materials is quite interesting as well. So for the offshore and the onshore energy domain, you've got robots that can actually climb up using magnetic wheels. This smart little chap's using fans to hold itself onto the wall so it can just move around on it. And lots of UAVs now are working right alongside buildings, which is an interesting area as well. Really dirty stuff, so cleaning out inside vents using a robot rather than a human. It's got to be a good thing. And you could even use that to go down inside a pipe and spray a lining inside it, potentially, couldn't you? So this is the sort of stuff that we mess around with, not the dirty stuff we play around with robots. So this next one, massive great machine, which is, was used in Germany. Looks just like a digger, but it's got loads and loads of sensors on it that make it fully automated. So it can drive itself around, it can operate its digger scoop, it can operate its grippers purely on its own. And not just that, but it's got a load of AI built into it as well. So it's doing some really smart stuff around moving materials around and starting to use rocks to build a wall by itself. So it picks up a rock, it scans it, and it works out what shape that rock is, builds up a whole library of rocks, and then it can start to say, what's the best way to build a wall using these rocks? That's it doing all its modeling, builds the wall, all on its own. So if you can do that, then surely you can fix a hole in the pipe, can't you? And then there's these little tiny robots. So this is the smallest little flying robot I could find on the internet. It's currently tethered, so it has got a little wire just giving it power, because it's really difficult to get the power source small enough. But that's a tiny little chap that can go anywhere. And everyone's doing humanoid robots. So this is the Tesla robot. That apparently was designed and built in 8 months. Boston Dynamics have spent millions and millions of dollars over many, many years. So everyone's just building the next step beyond it. But those will soon be available in the shops. Buy yourself a Tesla robot. So this one, I just wanted to give a little example of what we do. So offshore wind farms, really difficult things to manage and maintain. Currently you send out a diesel boat with 4 people in it 2 of them as divers, 2 of them looking after the vehicle. And they sit around by the wind farm, the divers go down, do a scan of the underwater structure, and then come back and report on it. What we're doing is sending out a solar-powered vehicle with 2 little remote vehicles underneath it that go underwater, use stereo cameras to scan the whole structure. So you get rid of 4 people doing a really dangerous job. Not only that, but you're building more and more wind farms, so you need more and more people or more and more robots. So just an example of the kind of thing we do. But what we say is, come and talk to us, look at what's in the Robotarium. This is our nice new building. It's now a year old, based at Heriot-Watt University in Edinburgh. This bit of the lab now is completely full of robots, and every day you go in there, there's another project being done. So we've got engineers messing around in there all the time, playing with robots. And we've got this lovely atrium bit, and all around the outside there, lots of hot desking, so you can come and collaborate with us. So really what I wanted to say to you today was, we're out there, we've got loads of skills to build robots, to solve people's problems, so come and talk to us. That's what we are. I've got a stand out there for tomorrow if you want to come and see me, and I'll be in the bar if you want to buy me a drink. So thank you very much. And now you can have your meal.